We're going to solve rational equations. This is the type of problem that we're going to end up building up to solve, but we're going to kind of lead into this so this problem makes more sense. If you look at some of these more basic problems, you'd probably think to cross multiply. Don't think of it as cross multiplying. You need to understand the concepts behind cross multiplying in order to do the harder problems like the one I just showed. So instead of cross multiplying and doing that shortcut, I'm going to multiply both sides by 2 so that the denominator here cancels, and by 7 so that this denominator cancels. So now we have 7x equals 5 times 2, which is what we would have gotten anyway by cross multiplying, and then x equals 10/7. So number 2, same thing. Let's multiply by both denominators. We'll multiply by 5 to both sides so that the 5 in the denominator cancels, and by 4 also to both sides so that this 4 cancels. So now we have 5 times 3 equals 4x, and we can solve from there. Number 3, sometimes if a number goes into another number that you're given, you don't have to multiply both by 6 and by 2. You can, and it won't give you a wrong answer, but sometimes you're making your work a little bit longer with higher numbers. So if we multiply both sides by 6, since a 2 goes into 6, since 6 is 2 times 3, we see a 2 there. The 6's here cancel, and we're left with 1 equals 6 divided by 2 is 3. 1 equals 3x, so then x equals 1/3. So same with this one, then x equals 3/4. Now moving on to problems a little bit harder. If you look at the 2, 7, and 14, they all go into 14. So if we multiply each numerator by 14, 14 divided by 2 is 7, and we still have the 1 up in the numerator. 14 divided by 7 is 2, still times 3, equals, those 14's cancel and we have x. So our goal is to get rid of the denominators, and then it makes it a way easier algebra problem. And then from there, 7 times 1 is 7, plus 2 times 3 is 6, so x equals 13. Now we're going to start looking at rational functions. We want to get rid of the denominator, so we can multiply both sides by x minus 3. Now we have x equals 2 times x minus 3, and we can continue to solve for x. So that's 2x minus 6, and x equals 6. Then because we had x's in the denominator, we need to double check that we don't get a 0 in the denominator. 6 minus 3 doesn't give us 0, so this is our final answer. If the denominators aren't already factored, it's going to help to factor them. So we can factor out a 2, and we're left with x minus 5. So if we multiply both numerators by x minus 5, it's going to get your x minus 5's to cancel. But we do still have a 2, so we also want to multiply both numerators by 2. Now those 2's cancel. So now we're left with 2 times 3x plus 7 on the left side, 5x plus 17 on the right side. 3 minus 5 doesn't give us 0. 2 times 3 is 6, minus 10, that doesn't give us 0, so x equals 3. And in the next video, we'll solve a couple problems that are even harder.